All right, so I'm just making a quick video going through a couple of these questions where factorizing can help you add or subtract algebraic fractions. So I'm going to do question 3, part 6. So x minus 1 over x squared minus 4 plus 1 over x minus 2. Just before I jump into that, I'm going to just make an analogy with just fractions without algebra involved. So if you are asked to add a quarter plus 5/12, you know that you need to get a common denominator. So this is the same thing as common denominator between 4 and 12 would be 12. So something over 12 plus something over 12. So what do I multiply 4 by to get 12? It's 3. So you multiply 1 by 3 and you get 3. What do I multiply 12 by to get 12? Well, I don't need to multiply that one. Like that one was already over 12, so I don't need to do anything with the 5. It is still just 5. So this is 8 over 12, and obviously you'd simplify that down. But I might refer back to that as I go through this first one here. So to simplify this, and they give you the prompt here that you want to factorize the numerator and the denominator fully, and that might help. So in this one here, it's the x squared minus 4, which is, I suppose, screaming out to be factorized. So instead of 4, I'm just going to rewrite that as 2 squared. So now I've got x squared minus 2 squared on the bottom, and that's something I can factorize. So I've got x minus 1 over x squared minus 2 squared factorizes to x minus 2, x plus 2. Plus 1 over x minus 2. Now, to add these, I need a common denominator. Normally, my common denominator is this multiplied by this, and I'd get x minus 2 multiplied by x plus 2 multiplied by x minus 2. But I don't need to multiply all of those together to get a common denominator. A common denominator between those two things is just x minus 2 multiplied by x plus 2. Because x minus 2, x plus 2 here is the same as this, so that is obviously fine. And then the x minus 2 here divides into x minus 2, x plus 2. So the x minus 2, x plus 2 here is like using the 12 up here. You don't need to use 4 times 12 is 48 as your common denominator there. The 12 will do. It is a lower common denominator that the 4 and the 12 both divide into. You don't need to use this multiplied by this as the common denominator, because both of them divide into just x minus 2, x plus 2. Obviously, the x minus 2, x plus 2 is, the x minus 2 also divides into that. So, looking at this, you haven't done anything with this part of the sum, so it is still just x minus 1 on top. And over here, it's x minus 2 on the bottom here, and then it's x minus 2 multiplied by x plus 2. So what do you multiply x minus 2 by to get x minus 2 multiplied by x plus 2? It's x plus 2. So I'm going to multiply 1 by x plus 2. First one there, I'm not going to do anything with for now. So x minus 1 over x minus 2, x plus 2, plus, it's 1 times this, so it is just going to be x plus 2 over x minus 2, x plus 2. There's a common denominator there, so you can just add those two fractions. So on the top, x plus x is going to give me 2x. minus 1 plus 2. So that is minus 1 plus 2. 2 minus 1 is 1. So plus 1. And then just over the x minus 2, x plus 2. And as I said, we generally leave the denominators there unexpanded. The reason for that is you might be able to factorize the top and then simplify by cancelling something with something on the bottom, and you're only going to see that if the bottom is factorized out as well. So I can't factorize the top there, so that's done. That sum is finished. I'll do one more. So I will do 5 part 1. So this one here. So 1 over x squared minus 9 minus 2 over x squared minus x minus 6. It just says simplify the following, but I think looking at all of them, you'll be doing some factorizing, and that will make it easier to subtract the fractions. Okay, so here I could multiply this by this, and that would be my common denominator. But by factorizing first, I'm going to find a lower common denominator. So x squared minus 9. So again, you can replace that 9 with 3 squared. So factorized, the bottom of that is x minus 3, x plus 3, minus 2 over x squared minus x minus 6. So you can factorize that using guide number if you want. I'm just gonna set it up, and I think it's a simple enough one, so it should be fine. So factors of minus 6 that add to give me minus 1, so 2 and 3. I want it to be minus 1, so x plus 2 there, x minus 3 there. So looking at my two denominators, I've got x minus 3, x plus 3, x plus 2, x minus 3. So the x minus 3 is repeated. So the common denominator here is not going to be x minus 3 by x plus 3 by x plus 2 by x minus 3. It is fine to just have x minus 3 by x plus 3 by x plus 2. So let's use that as my common denominator. So x minus 3 by x plus 3 by x plus 2. Sorry, I shouldn't have the 1 in there. I'm going to have to multiply that by something. I'll just put the common denominator in first and then sort out the top. So common denominator is x minus 3 by x plus 3 by x plus 2. Okay, and the reason that works as a common denominator is this divides into it, this divides into it as well. So the top of these fractions then, what do I multiply this by to get this? Well, it's the x plus 2 that's extra. So on the top, it's going to be 1 times x plus 2. Over here, what do I multiply x plus 2 times x minus 3 by to get all this? It is x plus 3. So that's what this is multiplied by to get this. So you'll have to multiply the 2 by x plus 3. So 1 times x plus 2 is just x plus 2 over all this, x minus 3, x plus 3, x plus 2, minus 2 times that, so 2x plus 2 times 3 is 6, over x minus 3, x plus 3, x plus 2, and then same denominator here, so you can just subtract the fractions, just be careful with this. So it's x minus 2x, so that is minus x or minus 1x, and then it is 2 minus plus 6. 2 minus 6 is minus 4, all over the common denominator of x minus 3, x plus 3, x plus 2. So nothing I can factorize out of the top to simplify that down anymore, but again, no need to expand that denominator out. So there is 5 part 1, and there is 3 part 6.